Good morning once again. So previously we had a discussion on how we are going to select the model, how we are going to select the architecture, how we are going to select the language, and finally how to do your programming part. Right. So next we have to understand the computational models in embedded design. See, we know what is embedded this system, what is the features of that one, right? How it executes, right? We all know this. As a user point of view, we were discussing. Now the concept what is giving here is with respect to the design aspects. Okay. So I'm just asking you that how you are going to think on what mindset you are going to build a embedded product. Is it or no? So when we think that I want my embedded device should respond to me like this. So for that one, what you are going to do and how you are going to implement them. Okay. So you have a take an example of an ATM, right? So I wanted to withdraw money, right? So in my account there is some amount and I want to withdraw suppose say 1,000 rupees or 2,000 rupees I wanted to withdraw. So I go to nearby ATM. So insert my card, give my password. So it will be asking me on the screen. So what you wanted to do? So whether you want to do cash withdrawal, so many options are there, like changing of a password or knowing the account statement, or many options which we can observe. Okay. So in that I wanted because I have already decided that I wanted to withdraw money 1,000 or 2,000 rupees. So what I do, I go there, enter my username, password, and I'm going to go for the option of cash withdrawal and enter the amount and I will submit. So once submitted, what operation the ATM will do? The ATM will go back to my source account, right? It will check how much amount is available in my account and how much I am requesting for the withdrawal, whether sufficient amount is there or not, everything it is going to check. And also it is going to check whether amount is available in that ATM machine itself or not. See, sometimes what happens in my account, money will be there, but in the ATM amount will be not sufficient. So it will not display or it will not give me money, right? So it will indicate money, it is temporary unavailable or money is not available or some problem available, it is going to display. So now as a design aspect, you have to observe. So when a condition is not satisfied, so it should display some amount of information, right? Whether stack is full, that is one example I'm telling. Vaccination drive we are doing. So we are giving token system, we are following a token system. So we will assign around 200 tokens. So whoever will come first in, first out. So first in who will come, we will give the token for them. So if you come afternoon or 2 o'clock or 3 o'clock, if you come, there won't be any vaccination available. Is it or no? So you are going to follow some procedure of identifying. And if there is no vaccination, that you need to display it or you need to put a message that. So before, one second. Okay, sorry for the interference. So here he is giving that how you are going to model, what conditions you have to give, how it will be displayed. If one condition is given, what should be the output. So all those steps is making us to understand. And accordingly, if we follow this procedure, what is the advantage is that we will be more chances of getting successful. Okay. So they follow some procedure to do. Okay. In a software also we have to follow some procedure. Hardware also we have to follow some procedure. So we have observed that thing in the lab also, right? So you what experiment we had done, so how we have done is that, so first we had written all the program, all supporting files we have had, then we have built, then we have taken the hardware, we have connected it, then we have assembled it. So we are following some procedure to get the output. So that is what we are trying to learn. Many of you will be knowing what is state diagram, what is conditional. So if this condition is enabled, what will be the output? So everybody knows that one. So that is the standard model procedure which we need to follow. That is what he is trying to explain here. Computational model. One second. Sorry, once again. So this is a commonly used computational models in embedded system designs which we follow. And again, it need not to be that we have to follow accordingly. Okay, that is not the way. Which is suitable, which is appropriate, that we have to use. Otherwise, what happens? Unnecessarily, we are doing all the process. Okay, so that is a common sense which we have to understand, right? So few application, a data flow graph model is required. Few application control data flow is required. Few application state machine diagram is required. Sequential programming model is required. Concurrent communication process model is required. Object oriented model is required. See, in labs also we observe these things. In SGL programming, you should write the flow chart, you should write the code, right? You should write the truth table, then you should write the waveform. In embedded lab also, you should write the program, you should understand the logic, you should write if any conditional is there, header file is there, those things you should write. Finally, with the output, we have to write with a showing result in the registers, right? So these are the few different labs having different procedures. So we are not following all one procedure, right? So here also for depending on the embedded application, you need to find out different in a different sense. Okay. So data flow graph diagram model. This is a flow diagram model which we are going to follow, because every time when I want to write a program also, first I will make sure that I explain the logic first. And to explain the logic, normally I will take, because when I'm explaining that multiplication of two number, so I was storing one number in one register, one more number in one more register, then I will do multiplication, then value will be stored into one register. So I use those registers blocks to explain that program. Okay, for even number, for odd number also, I was drawing that bit value and I was checking that LSB bit. So some procedures we have to identify so that it will be, means I should make in a presentable way so that you will understand the things properly. Okay. So it is a data driven model in which the program execution is determined by data, because we have observed a data flow model, kind of what we call high level language model. Then we have multiple switch case model, right? We have different kind of things which is present, which we will follow. This model emphasizes on the data and operation on the data, which transforms the input data to the output data, right? So in whatever way you want to give the data, you can do it, right? But finally, what is expected? I want the output. I want the expected output, what it should be. Whether you are making things complicated or whether you are making things simple, it is left to you. This is the input. If I give, I should get an output. So if I take a full ladder program, so I will give three inputs A, B, C, and I want expected output, sum and carry. That is the thing. Whether you do sum equal to A XOR B XOR C, or you do some other operation, whatever you do, finally I want the output. Right? There are different ways of doing embedded application which are computational intensive and data driven or modeled using the DFG. DFG is nothing but your data flow graph or diagram model. DSP application are typical examples of the this DFG. DFG is usual visual model in which the operation of the data is represented using a block and data flow is represented using the arrows. An inward arrow or to the process circle represents input data and an output arrow from the process circle represents the output diagram. So in the flow chart we will tell whether in black box also we were writing whether data is input or whether data is output. So, sir, what is there? Why you have to represent? These are all very important thing, right? Example, take with a theater, right? So you take the mall. You have a entry, you have a exit, and you should enter only through that gate only because for n number of reasons and n number of reasons you might be knowing what it is used for. Okay. Suppose here we what we call it as a LHS and RHS where your all input will be on the RHS and your output will be on the LHS, right? So you will be knowing what it is. X is your output, A and B is your input. Now X is acting as an input and output. So we can observe that one example is given X equal to A plus B and Y equal to X minus C. So X, if I want, I should get data from A and B. So my input is A, B and C, right? So A, B, if I do, I will get X and C if I give, I will get Y. So that is the one graph model which we can build for this expression, right? Everything it is mathematically written, okay? Every design aspects you can mathematically do and you can perform in the real time. That is also possible, okay? So this is one example of a data flow where you can see A, B, you can see X, you can see Y. You may be saying, sir, why this diagram data flow node? We call this circle as a data flow node. Why it can be parallel? Okay, plus here minus here. I am showing in the arrow mark. Why it can't be here? Why? Because it will take some amount of time. Okay, A it should read data A, it should read data B, it should perform operation of addition, and you should get result at X. Once you are writing your data in X, then it should perform X minus C. Is it or no? So it will take some amount of time. That is why this graph will be like this. In any way you can write it, there is no problem. In a DMG model, a data path is a data flow path from input to output is said to be a cyclic if it is does not contain multiple values. Cyclic it is only that if it is dependent or not dependent. See, now I am all dependent, I am the output, I have to take a class to you. Is it or no? But you are all inputs. My inputs are 57. But out of 57, now the attendance is 44. Right? So still few people are absent. So if input is not present, whether I have stopped, no. I have waited for some amount of time. I need to deliver. Otherwise, what happens? I cannot complete my portion for those people who are not attending it. So what they can do who is not attending it, so video recording is there, so they can download that one and they can observe what topics I have done. Or if they feel that my internet will go and all those stuff, then what they can do is that they can read on their own by having the material. So these slides and everything it is provided to you. So you will take that one and you will do. Right. Some feedback is also provided for these graphs. Right. So if my voice is not audible, my PPT is not you are not able to view. So you will give an indicating me, sir, PPT is not visible or voice is not audible, so that we can plan accordingly how we can improve it. PPT is visible, right? PPT is visible.
Yes, sir.
Yes, sir.
Okay. A DFG model translates the program as a single sequential execution. So you know execution also whether it is a sequential, whether it is a parallel. So what is the advantage? If it is parallel, how you are going to manage. So everything we need to take care of. Next is with respect to control data flow graph. So control data graph means what I am doing. See, if there is no authority or controlling part, then what happens? Whoever can enter to this lobby, they can disturb the class and they can disturb the session. Okay, for control everything it is under me. So I am disabling everyone. Means I am not giving everyone permission to present your slides because those are all disabled. So if I enable that one, any can unmute themselves. Anyone can mute myself. So it is all with respect to the organizer which we have given. So in the embedded system also you can have this control data flow path. Example again I will take example of with respect to the washing machine. So what happens? Washing machine is there. Have switch on the device. Everything it is working fine. Right, 15 minutes it is working fine. Then what happens? In my home, it's also there. So they will go to this embedded device. They will press any of the buttons. That is why to avoid this kind of in between interrupts, what they do is that they will go for this parental parental app or parental mode it will be there. So parental mode what it is that it will disable all kind of thing, only power supply will be enabled. So if my kids switch on or try to switch on those keys also it will not function. That also we have in the automobile also, four-wheeler also, parental lock we call or child lock we call. Generally we have heard about this child lock so that so kids cannot open the door. So you need to authorize from the driver itself to open that child lock. Right. So these are a few examples which I can share with respect to the control data flow diagram. Means what you have a control. Okay, there is no restriction there. Okay, the control DFG model is used for modeling application involving conditional program execution. CDFG model contains both data operation and control operation. CDFG as an element and conditional construct as a decision maker. CDFG contains both data flow nodes and decision nodes, where it contains only data flow nodes. Right? Consider the implementation of CFDG with an example. See here is giving a condition. If flag is 1, x equal to a plus b, else y equal to a minus b. So I wanted to do addition and subtraction. So if flag is 1, I do addition. If flag is not 1, I will do subtraction. So one condition which I am fixing so that it can be enhanced, right? So this requirement contains a decision making process. A decision make process you are going to do in a flow chart. We are going to give in a diamond. Okay. So flow chart you will be knowing condition everything you are writing in a diamond shaped data. Right, I think we have an example. So here you can see this is a flow chart. We have a dimension. If flag equal to 1, if it is true, then A plus B. If flag it is not 1, so it is false, it is performing A minus B. So this is how we are going to build the control data flow diagram. I hope you will be knowing these things which has been performed here. Okay, so this is a simple example of performing based on the flag condition. Right? A real world example for modeling an embedded application using the CFDG is capturing and saving the image to a format set by the user in a digital still camera. So camera example is taken. Analog front-end converter CCD sensor generated a analog signal. The data ADC is stored in a buffer. Then autocorrection, white balancing, adjustment, everything in form. Finally, you are having an output in the form of JPEG or TIFF or BMP bit format or joint format or TIFF format. These are the camera settings which you can add. Next is important is your state machine model. So based on different state in ITC also we have observed that in the last convolutional coding we had created state diagram, state condition, next state, present state. So if input is 0, which state it will go. Tree diagram we have done, right? With the algorithm we have implemented. So we know all these things. What is a state diagram we have understood, right? And this state diagram is a mandatory for the embedded device. So if it is in this state, next state, whether it has to reset or whether it should go to the next state. So that information we are giving, right? So we are making some condition or state, and we are performing or building some events, and based on that event, some action and some transaction should happen. See, if take an example of an ATM. So card I should insert, password I should insert, money is sufficient, everything is a different state, and everything if it is satisfied, money will be outputted so that I can withdraw it. Is it or no? So that is the work which is been done with the help of this state machine model. Is used for modeling reactive and event driven. So reactive means what? If I insert a card, then only I am going to get an amount. Right? Event driven is what? It will perform some operation, then finally it will give the result. That is a event driven type of a thing. Immediate or some process which will follow. Embedded system used in the control and industrial application are typical example of the event-driven system. The state machine model describes the state behavior with states, events, actions, and transition. State is a representation of a current situation, and event is an input to the state. The event acts as stimuli for the state transition. Transition is a movement from one state to another. Action is an activity to be performed by the state machine. Finite state machine, we have this. Generally, we call it as a FSM. Okay. Many embedded textbook, if you observe or a microcontroller, we find this FSM model. Right. FSM model means what? Finite state machine means what? There is some input should be there. Then based on that input state, it will perform some operation. Okay, that is the meaning. The finite state machine model is one in which the number of states are finite. Finite means for performing data, you should require some input. Without input, it is not going to give the output. Okay, some input which you have to do. Suppose say internet banking. So username I have given, password I have entered. Then I need to press submit. Only if I fill the username and password and I wait whether it will open, it will not open. You have to press submit button. When you submit button, it will check whether your username and password is matched. Then only it will open. That is a condition which we have given here. The system is describing a user using a finite number of possible states. See, in the embedded system, it is not that every time you will get input data always. Okay. So we have your input and I am the output who I am going to take the class. Now inputs, everyone will be present? No. If there is no input, still I have to perform. That is what I am doing here. Right? I am not waiting for example you take buses also. So bus if it is full, then only it will travel. Okay. So it is not that case. You take about government buses and private buses. Private bus, he will wait for half an hour or 1 hour delay also, so that he will make full. So all the seats are full, then only he will leave. But take about government bus. We are scheduled for 10:30 departure. So at 10:30, whatever no, if no one is coming or nobody is arrived also, at 10:30 they should leave. Because I have booked. For that only I am paying. Why they are for booking they are taking charges? Because it will be scheduled on time, and on that time only it should leave. And if it is not leaving, then you can ask the driver or you can complain to the BMTC or KSRTC stating that I have booked exactly at 10:30, but still the departure is not possible. And obviously, not everything it is correct. I also scheduled for 9:55, but I have started around 10 o'clock because 5 minutes I need to wait for you people to join. That is a thing. So in India, not only in India, everywhere it is those kind. But examination and all those things, if you take military application, 5 minutes I will wait, 5 minutes you should wait, 5 minutes if I wait, so many things can be possible. Example, traffic. 5 minutes if you are delayed, usually you would have got in around 30 minutes. If 5 minutes is delayed, then you will get into the campus by 1 hour late. So you know all this observation, which is a general observation which we can see. As an example, let us consider design of an embedded system for a driver passenger seat belt warning in an automotive using the finite state machine. The system requirements are captured as when the vehicle ignition is turned on and the seat belt is not fastened within 10 seconds of the ignition on, the system generates an alarm signal for 5 seconds. Now you take for any vehicle, okay, any new vehicle when you are purchasing now or past 6 months when you are purchased, so seat belt it is mandatory for the driver, you need to wear it. Otherwise, your ignition will not on. So that is what is giving the information. So if seat belt is not means put, so ignition will be off. The alarm is turned off when the alarm time expires of it. So these things we have to write in a finite state machine. So here are the states. Which are the states? Alarm off, waiting, and alarm on. The events are ignition key on, ignition key off, timer expire, alarm timer expire, seat belt on. So you should understand what is defined as a state and what is defined as a event. So state is indicating to which level the alarm is on. Alarm it will be not every time on. So alarm is on only when you have some condition. What condition? Your condition your seat belt is not on, then alarm will be on. So that is how they have differentiated the state machine, your states and an event. Okay, so this is a state diagram which is there. So alarm on, alarm off, and waiting, because these are the three states. Okay, alarm off, waiting, alarm on. See, now I will go this alarm on. Okay, so alarm on, when it will do? When seat belt on, ignition key is off, alarm time expires, then for this condition. I think there is wrong here. Alarm is on when seat belt is off. Okay, when seat belt is on, then you don't require anything. Timer expire, now alarm is off. Alarm off indicating that you have wear the seat belt. So when you have wear the seat belt, then what indication we have to give? Ignition should be on. Right? When I wear a seat belt, then what happens? Ignition should start. When I don't wear a seat belt, then what? Ignition should be off. And during that time, it will be in the waiting state. So that is what is explained in this finite state machine part. Okay. So condition and everything, occurrence and everything you can observe here. One more set which we call in the technical kind, it should be idle, it should be ready, it should be in running. Right? So idle state means what? I need to wait. So during that wait time, I should pass. Then I should present all these slides. Means I should display screen and everything. So my screen is visible, my voice is audible, everyone are present. Then I will be in running state. Okay. So it is with respect, because this is with respect to high level language which we will understand, and this flow diagram it is with respect to the device level. So device level will not understand whether it is full, whether it is on, and all those stuff. It will be only in the idle state, ready state, and the running state. Okay, so same example he has given here. So example one, design an automatic tea coffee vending machine based on a finite state machine model for the following requirement. The tea coffee vending is initiated by user inserting a 5 rupee coin. After inserting a coin, the user can either select a coffee or tea or press cancel to cancel the order and take back the coin. So in a simple example, coffee vending machine put, because still it is not everywhere. Now we have all these things, now coronavirus and everything is there, right? So you may be thinking that one filter coffee machine, vending machine can be installed there. So whoever wants, they will go put money, cup will be there, you have to take that one, whichever you order you select that one, so it will come and you need to take. Now here also in the cafeteria also coffee vending machine is there, but there is some person who is doing this operation. Okay, but actually coffee vending machine it is what it should do on its own. Whoever wants, they will go on, they will do. Maybe you might have observed in the offices, corporate offices you will have, but there you no need to pay 5 rupees and all those things. Only go there, select that one, you will get the things. The finite state machine model contains 4 steps: waiting for coin, which is the first step; waiting for the user input, which is the second step; dispense tea, which is the output; dispense coffee, which is the thing. One more it is not given is that if it is cancelled, money should be back. So these are the state he has not given, money lending part, which I can add. So state A, state B, state C, state D. So orally you can understand. This is the task which I will give. Which I will give for someone, and they need to present me tomorrow. They need to explain this finite state model. So I will choose one of the person. I'm just seeing who can present that one. Hmm, Darshan. 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 ರೆಸ್ಪಾಂಡ್ ಮಾಡ್ತೀಯಾ ಆಬ್ಸೆಂಟ್ ಮಾಡ್ಬೇಕಾ?
Yes, sir.
Uh, Tomorrow, this example one is there, right? Finite state machine. This state diagram you need to explain. Okay.
Okay, sir.
Example one, finite state machine. Okay. Example two, design a coin operated public telephone unit. Okay. This is second example. So I will choose one more person. Jyotika. Jyotika.
Yes, sir.
Respond ಮಾಡ್ಬೇಕು. Second example ನೀವು ಮಾಡೋದು.
Okay, sir.
Second example is what? Design a coin-operated public telephone unit based on finite state machine. So these are the condition. If line is busy, if line is through, right? System is ready. You know what is a telephone, how it operate. So you need to explain this state diagram. Okay, na? So this sequential programming model we will do in tomorrow's class. So Jyotika will explain us example one and example two. Okay, na? Quiz is open. No open ಆಗಿಲ್ಲ quiz. Checking.
No, sir.
Open ಆಗ್ತಾ ಇಲ್ಲ. I think you have got correct. All
Yes.
MCQs
Yes,
it
sir.
is, so you can attempt. Okay. And I have given assignment. Today is a deadline for that.